In this video, we will be basically seeing certain kind of specialized feature based options which are available in SolidWorks. These features which we'll be covering up in this video are rib, shell, draft, intersect, and wrap. All these features are something which can be told as a kind of specialized features which are used for specialized kind of operations over different parts in SolidWorks in part modeling. Like we need to have certain kind of ready 3D parts onto which this can be a specialized kind of operations which can be carried out. Now these things, the features which we are like going to discuss in this video are certain kind of features which require certain kind of predefined objects as in 3D objects, and we need to provide certain kind of contours or close sketches using which then the operations can be laid out onto the existing 3D objects. That's why they are also called as specialized features in SolidWorks. Like for example, rib. Now rib is a special type of an extruded feature which is created from open or closed sketch contour, and the material is provided of like specified thickness in a specified direction between the contour and the existing 3D product. And by selecting multiple sketches also we can create the rib. Now the rib features which we can also alter are by providing the draft or select a reference contour to draft. So basically rib is a simple kind of a feature which requires certain kind of entities of sketches for providing to the existing 3D, and it the rib in practical approach is provided to objects wherein like we need to have certain kind of strength to be provided to the parts, and by providing, instead of providing a complete material cover up, we can provide certain kind of material thicknesses, and these thicknesses are ribs. So as in the screen we can see, like if we have to create a rib, for example if we are creating a rib for a L channel or an L-legged object, so basically first we will be just creating out certain kind of an L-legged object using which onto which then we will be just putting out the rib feature by using a simple sketch. So in this manner rib can be provided with certain kind of thicknesses, and this thicknesses can be altered as per our requirements, and also the directions which are to be provided to it can be also altered. Apart from it, we can also provide like multiple sketches using ribs, and this can be done by creating the different multiple sketches and then selecting the rib features. So once we have created the L leg, now to provide the rib we need to provide it somewhere which is between the 3D sketch, and it needs to have entities which will be crossing the existing 3D model at its ends. So the plane needs to be created as such which will allow us to do the same. So for that we will be just intersecting both the faces onto which we are to create a rib, and the rib from sideways can be also told as a taper support which is like given between the two surfaces, and using this we can just select the rib feature, and by which we can just understand how the rib features can be done. So the directions which can be provided, it can be directional, bidirectional, and it can even be, we can even change the direction from the sketch orientation. So using that thing we can do, but the sketch orientation needs to be kept in mind that if it's available for that kind of a 3D part. Now for this sketch orientation we can use only one type of sketch orientation which is like alongside the sketch, not off the ways of the sketch, upper or the downside. So that's why the SolidWorks will predict it and just show us an error when we try to create it as sketch. So this is the way the ribs get created up, and that's the way how we need to actually understand how to create the rib and what kind of modifications we can make into it. So the next feature which we'll be like looking after is going to be the shell feature. Now as the shell, the name goes, it just hollows out a part, it shells out the part, so it leaves us with the open surfaces, and using which we can just create parts for creating out hollowed surfaces and all. So it creates thin walled features on the remaining faces. So basically if we want to create the same thing using certain existing major features which are available like the extrude and extruded cut, we'll have to use this combination of extrude and extruded cut to hollow out certain kind of a rectangular surface or a cubical surface. But with the rib surface, with the ribs feature, we can actually do it up by selecting directly the face onto which we have to give it. And onto ribs we can also provide it onto the outer face or onto the inner face, and then we can just make the changes as we need. Also it can be provided with uniform thickness or with multi thickness faces, wherein like each and every face can be altered with different kind of thickness, and we can just remove the faces and set the default thickness for the remaining faces, then setting the different thicknesses for the faces which can be selected from the remaining faces. So this is how basically shell is created out. And it just it is a tool which has like problems certain times, like error diagnostic section appears as and when we just need to identify that what kind of shell failure has occurred. And by understanding that, most of the times these errors get rectified because we need to provide a certain kind of exact amount of faces onto which we have to do it. And then the next feature which we'll be talking after is the draft feature. So draft is basically a tapering of the face. So it is used in like specified angle on selected faces in the model. And once draft is applied to a part, a draft feature will apply in the scene browser and for reference and for editing. So draft can be applied to like solid or surface models. And there are like three types of drafts available: the neutral plane draft, the parting line draft, and the step parting line under the manual mode of draft. And so for neutral plane we need to create certain kind of surface onto which we need to keep it as a neutral, and we need not be able to change it, and then click the face onto which the draft is to be applied. So draft is basically a taper face. So as you can see in the screen, if we just create a neutral plane, then we can just create that thing using by giving and identifying the exact phase where we need the taper and what amount of taper we require, that thickness or the angle we need to provide. Mainly we need to provide the angle, and if we want to just know the thickness, so then basically we need to adjust the angle as per the required thickness, and that's how we can just get it. Apart from it, the other two types which are available are the parting line and the step parting line. But for that thing what we require is to create a step part, or basically we need to split the face onto which the draft is to be created out. So for that thing we need to just create certain kind of a curve or certain kind of a line with edges, using which then we can just split the face using a split line feature, and this thing will just split out the face into two different parts. And then onto this thing, by using the boundary line, we can just provide the draft feature entity as input, and that thing can be used to just create the required draft as in of the two types which are available, which are the parting line draft and the step parting line. Now both these drafts differ in just one way, which we can just understand by using both the features one by one. So this all process is like it, we need to even look after the direction which is provided in the draft. And then apart from it, there are like different kind of advanced options like reduced angle or perpendicular step or draft, using which we need to understand basically how and when this kind of features can be used in drafting and drafting of a face. And so this is way like we need to give the pull direction angle and then select the correct amount of faces. So as we can see, as we have seen on the screen, both the faces both the types of drafts vary by altering the neutral plane face. Now in the parting line draft, we just defer the neutral plane face which we have selected as per the thickness, but in a step draft we just provide a step onto the sketch contour which we have selected, or the parting line which we just selected. So under the face selection filter also we have got certain options like select certain kind of faces directly, or it's like along the tangent, and this just extends the draft of to all faces that are tangent to the selected faces. Apart from it, we can just select all the faces, or like only the inner faces and only the outer faces from the neutral pane. And by that, even also we have got certain kind of advanced options into it, which are like the reduced angle, and which allows us to allow only the parting line draft. When selecting this option, this draft angle on some portions of the draft faces may be smaller than the specified draft angle. And apart from it, we have also got a perpendicular step draft. So now we are just looking after the next feature, which is the intersect feature. Now intersect feature is simple to understand because it just intersects the plane, any face which we want to create, and it in the end it just creates out two different bodies. So basically this phase requires to create a simple entity, and it helps us to just perform a complex operations in very quickly by combining different surfaces, planes and solid bodies without the need for multiple cut, trim, fill and knit features. So it is a very time saving process. So here in as in we just created a curve, out of which then we just selected the curve and just splitted the face, and using that curve then we just created an intersection plane by surface modeling, and which was just extruded, and then selecting the exact bodies which we have to keep and exact bodies which we have to cut, we can actually remove out the exact surfaces and just get the end product as we require. So this is how this whole thing of intersect basically works out, and we need to actually understand how these features can be used in the most easiest manner possible. The next feature which we will be looking after is the wrap feature. Now the wrap feature enables us to wrap 2D sketches around cylindrical or conical faces. But however we need to try to wrap around 360 degrees can cause some difficulties, because we need to understand the circumference of the part also onto which we are wrapping up. So basically this feature works by flattening the face, relating the sketch to the flat pattern on the of the face, and then mapping the face boundaries and the sketch back onto the 3D face. So the reason why it is limited to cylindrical and conical faces is that these types of geometry are developable. This means that the faces can be mapped to the flat pattern through some relatively simple techniques that happen behind the scenes. So now we will just understand how this wrap feature can be actually worked out. So for that thing we'll have to create a certain kind of a cylindrical surface, and for that thing we just created a cylindrical body, and then we have to just create out a plane which is tangent to the surface over it, because tangential surface will be basically easier to design, and the software can predict out that how the sketch has to be embossed or debossed onto it, and how it has to be actually wrapped around it. So on that plane then basically we'll have to create out a simple sort of a spline based structure which needs to be a closed one, because even it cannot be a self intersecting one, because this structure which we'll be creating out, or a sketch which we'll be creating out, will be actually converted out into a part model, and it will be embossed, debossed or scribed, or basically wrapped over the cylindrical body which we'll be selecting. So once we select the sketch and then just click onto the wrap feature, we are just taken to the property manager wherein like the sketch is pre-selected itself, and using that thing then we need to just understand like how and what kind of requirement we have, that is basically emboss, deboss or scribe. So these three things which we are like talking until now, they have meaning into them. Is that emboss means like as we emboss certain kind of thing, and like as you see on the screen also, this emboss thing, it just embosses the sketch entity which we have just created onto it, and it just gives you the exact amount of thickness as per the distance you mention, and the distance which is calculated is the maximum distance is at a certain point, which is from the it is calculated radially, and in the same way it goes with the deboss also, which just does the opposite of emboss, and it just extrude cuts in certain way which we can say. And so it's like the same way as boss and the cut features, which are like the major parental features of features, and this is the way this thing works out. And the last one is the scribe, which just scribes the sketch onto the surface. And this is how the complete kind of customizing of the existing features, or like providing certain kind of specialized features in SolidWorks is done using this variety of features like wrap, draft, rib, shell, intersect.